Hello students, in the previous module we discussed Ohm's law. In this module we will discuss what are the factors on which the resistance of a conductor depends. Now we will see what are the factors depends upon the resistance of a conductor. For that we will do this activity. First, we will take a nichrome wire having a specific length, that is this one. We connected across these terminals and measure the current through this ammeter. Then, after that, we increase the length of the nichrome wire and again see the current. We can see that as the length of the conductor increases, the current decreases. Now, we will take the same length wire but different area of cross section. One thin wire we will take and note down the ammeter reading. Then thick wire you take and note down the ammeter reading. You can see that in thick wire the ammeter reading is more, and for thin wire the ammeter reading is less. So we can see here the resistance of the conductor is directly proportional to the length of the conductor, and the resistance of the conductor is inversely proportional to the area of cross section. As the area increases, the resistance decreases. As the length increases, the resistance increases. A conductor having some appreciable resistance is called a resistor. A component of identical size that offers a high resistance is a poor conductor. An insulator of same size offers even a high resistance. It is observed that ammeter reading increases to 1/2 when the length of the wire is doubled. The ammeter reading is increased when a thicker wire of the same material and of the same length is used in the circuit. A change in ammeter reading is observed when a wire of different material of same length and the same area of cross section is used. The reading is observed when a wire of different material of same length and same area cross section is used. Okay, that means when we are using, because I told you to do this experiment with a nichrome wire, but if you do this experiment with a copper wire, we can see that the reading will be different. If you take a copper wire and a nichrome wire, both are having the same length and same area cross section, we can see that the ammeter reading is more for copper wire. This is because the material of copper is different from nichrome. So a change in ammeter reading is observed when a wire of different material of same length and same area of cross section is used. Resistance of a conductor depends on its length, on its area of cross section, on the nature of its material. Precise measurements have shown that resistance of a uniform metallic conductor is directly proportional to its length and inversely proportional to area of cross section. That is, R is proportional to L and R is proportional to 1/A. When we combine these two, R is proportional to L/A. That is, R is equal to rho L/A. This rho is a very important physical quantity. This is the resistivity of the material. This is called the constant of proportionality. Rho is called electrical resistivity. The SI unit of electrical resistivity is ohm meter. It is the characteristic property of the material. The metals and alloys have very low resistivity in the ranges of 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. You know that we are using different material for different purpose. Heating devices we usually using alloys, and in the incandescent bulb the filament of the bulb is made up of tungsten. Then the connecting wires, it is made up of copper. Why we are using different material in different purpose? It is based on the resistivity of the material. First we will see why alloys are used to make the heating devices. The reason is that resistivity of an alloy is generally higher than that of its constituent metals. And main thing is that alloys do not oxidize readily at high temperature. You have seen that your electric oven and all, it become red hot, but it will not be melted. If you use copper wire, that it will be melted within a second. But we are using alloys, it will not be melted because its high resistivity is high and it will not be oxidized at a very high temperature. Then tungsten. The resistivity of tungsten is very high. That is why we are using tungsten in a filament. And resistivity is high, and another quality is that it can be drawn into very thin wires, and other one is that its melting point is very high. Then why we are using connecting wire as copper? The reason is that the resistance of the copper wire is very less. The resistivity is less. In the form of heat is very less. That is why we are using copper wire in transmission lines. This table shows the resistivity of conductors, alloys and insulators. You can see here the alloys, its range of resistivity, it is coming in power of 10 to the power minus 6, and conductors, it is coming 1.6 into 10 to the power minus 8 to 1.84 into 10 to the power minus 6, and insulators have a very high resistance.